We've got the drawing. We know how, in theory, to wire up a potentiometer. Now let's actually do it. Well, so the first thing I'm going to do is take a potentiometer, and I'm going to plug it in like this to my breadboard. I plug it in sticking off the edge. Why? Because I'm going to want to turn it like this. You might also think, well, maybe I'll plug it in like this, sticking off the edge. So convenient. Well, look carefully at what you would have done if you did that. You would have been attaching all three legs of the potentiometer to each other. That is like making a wire that connects this to this to this. It doesn't do much. So we need to put those three legs in three different rows. Otherwise, this isn't really useful. And by the way, the spacing of the legs on the potentiometer is 1/10 of an inch spacing in between. These match the holes in the board, so it'll just plug right in. Now we want to get power to one side and ground to the other side. These are the outside legs of the potentiometer. Power is not present here on our breadboard. Ground is, because we connected this wire. Well, I'm going to use a red wire to connect from 5V. That's the 5-volt pin, and I'm really careful to plug it in at the right spot. I know it's upside down, but that's plugged into 5V. And I'm going to plug it into this column over here, the plus column on this side. Now, sometimes people will plug these in like that, which is perfectly fine because those columns just run parallel to each other. They don't touch each other. But I like to keep my power and my ground really far away from each other so I don't accidentally short things out, because connecting them together can break stuff. So I now do have power on the board. It's over here. I've got ground on the board. It's over here. It's a good idea to start by connecting grounds rather than powers to things, because ground is kind of the 0 volt, the safe standard, as it were. So I'm going to actually take a little black wire and connect it from ground to the left leg. In that case, it's the leg closer to me of this potentiometer. That's the outside leg. And do be careful about where you're plugging it in, because it can be easy to get in the wrong row. So take your time and look what you're doing. Now I will connect power using a red wire. Red because I'm always trying to use good colors, into the right leg of the potentiometer. And now finally, there's the middle leg of the potentiometer. So that was connecting power to one outside leg, ground to the other outside leg. The only thing left to do is the middle to A0, which is as simple as a single wire. I'm going to use a different color for this. It's just a wire that's going to be carrying a voltage. And so I'll use yellow, sure. And I'm going to plug it into A0. The wiring is complete. Now that the wiring is complete, let us move on to the software piece. We're going to, and I've made a new sketch called Read a Potentiometer. So I'll say read a potentiometer's value and print it to the computer user. Now, we're going to have to find out how to do this printing thing, and we're going to get to it. But for the moment, we'll just read the value and print it. We know that's what this sketch is going to do. The first thing I'm going to do is, I should have said attached to pin A0. I always want to make a note to myself of where stuff is plugged in. That's a really good idea. So how do I actually write this? Well, void setup is a pretty good place to begin. Pin mode. The pin is A0. I know that doesn't look like a number. It looks like a letter and a number, but for the Arduino software, that's fine to do that. And the mode is not an output. Rather, it's an input because the data is flowing into the Arduino. Okay. Now in the loop, I'm going to do this function that we haven't seen before, which is called analogRead. Now, analogRead takes only a single argument, meaning a single thing in the parentheses, which is the pin it's doing the analog read of. Unlike digital write, which had the pin and what should I tell it to do, analog read only inputs information into the Arduino. So we don't have to tell that pin to be high or low, we just read it. So you might think, okay, well, I've done my job. I'm doing the analog read. I'm completely finished. And in fact, just to make sure, like, would this even work? I can hit the verify button. It'll compile sketch. It'll say done compiling, meaning, yes, this software as written it works. But does it really work? Does it actually do anything? No, because even if I were to upload this to the Arduino, nothing especially would happen running this software. What I want us to do is give information back to us, the users who are looking at the software. And it's actually possible to get live feedback back to us while the Arduino is plugged into the computer. It's a really powerful tool, and this is the first time we're going to do it. But before we get to that, I want to say something about this line. This is the equivalent of asking somebody, hey, could you go look at the clock? And the person like dutifully goes over and looks at the clock. And then you never ask the follow-up question, what time does the clock say? So this will do the job of looking at the clock, but we want to get the answer out of it and actually store it somewhere. So we're going to do something we have not done before. We're going to make a new variable. It's of type int, which is short for the word integer, which you might know from mathematics. It refers to like a whole number. And that's similar to what it means here in computer science, though certainly not identical. We're going to say int potval equals 0. So what is happening on this line? We're making a new variable of type int. That is what that first 3 letters says. I'm making a new variable. Calling that variable potval. Why? That's short for potentiometer value. And setting the value of it to 0. This line here, potval, or this little thing that I've highlighted, potval equals 0, that is not the same as the mathematical statement potval equals 0. It's not a statement of fact. Rather, it is an action. We're telling the Arduino, take the number 0 and put it into the variable called potval. Make the value of potval be 0. And from here on out, until something changes it, whenever I say potval, I will be referring to the number 0. If instead I were to say potval equals 8, then whenever I said potval later in the sketch, potval would be holding the number 8. A variable is a named value. So what we're going to do next, now that we have a variable, a place to put the answer, we're going to do the analog read. Sure, I'll leave it intact as is, but I'm going to say potval equals analog read. Do the analog read and store the value into potval. So now potval contains whatever the result of analog read was. Could have been 5 volts, could have been 0 volts, could have been 2.5 volts, whatever. It's going to be stored in that number, potval. Now, I'm going to do another trick, which is Serial.println, and I'm going to say potval in the parentheses. What this line is doing, this line send data back to the computer. Specifically, send potval's value. What this line does, it's if you have done computer programming before, you might be familiar with console feedback, like sending data back to the user. Sorry, my video froze. I will unfreeze it. I have a hardware issue, as you might have noticed. So what this is doing is distinct from that. It is actually sending data back through the wire that connects to the connects the Arduino to the computer. That is through the USB cable. It's going to push data back to the computer. Remember we saw that RX and TX lights blinking before when data was coming into the Arduino? That was the Arduino, getting its new programming. We're actually going to be doing something different where we're pushing numbers back to the computer. And we'll see how to read those numbers. One more thing we have to do, since we are doing this serial number pushing trick, in the setup, I have to add a line, which is serial.begin, and then in parentheses, 9600. What this line does is start serial, or I'd say rather open the serial communication port to talk back to the computer. All right, this is our sketch. I'm going to save it, and I'm going to verify just to make sure. Does it work? Compiles? Yes, it compiles. So now I'm going to upload it. That means I'm going to have to plug my Arduino in, and when I plug my Arduino in, I'll show you what it looks like. Well, it's blinking. Why? Because that's the last sketch I ran. I didn't do the homework that said make the two lights do this. I just did the blinking as you saw. So I'm going to upload the new code, and I like to look at both the Arduino and the code as it's uploading because I think it's kind of useful. So I'm going to hit upload. Let's see what happens. Okay, I saw those blink, and now notice it's done uploading and the thing stopped blinking because my new code has nothing to do with that blinking anymore. And the TX light is just illuminated like all the time. Why is that? Because the Arduino is now doing what we told it to do, is just sending data back to the computer. It's sending and sending and sending and sending and sending. However, we are not yet reading the data. How do we read the data? In the Arduino software, there's a little button up here in the upper right-hand corner called Serial Monitor. What Serial Monitor does is allows you to read information coming from the Arduino. I want to click on that. I'm sorry, my Serial Monitor opened in a funny place. So I'm going to put it in a place where we can see it. And the Serial Monitor has a bunch of numbers. I want you to select in this selector here the number 9600 baud. And now notice that there's just a whole bunch of numbers changing. Now, what I'm going to do is split the screen so that you can see both my hand over here and the serial monitor, and check it out. As I turn this thing up, those values are going higher and higher and higher and higher. When I go all the way up to the right, it's this interesting number, 1023. And if I go all the way counterclockwise, it goes down to 0. And it's pretty quick. So as I move pretty quickly, I'm seeing those numbers change. You should see something that looks kind of like this. But wait, there's more. Let's say instead of seeing a whole bunch of numbers like that, you actually prefer seeing a graph. There's actually a built-in function to the Arduino software. So I'm going to close that, go under Tools, Serial Plotter, which is different than the Serial Monitor. The Serial Plotter, I'm sorry, mine has opened again in a funky place, but I will put it back in a place that's visible. So please notice that this is an auto-ranging graph. It actually will choose its y-axis based on the data it's seeing come in. The x-axis is the number of the data, the point that's come by, how many data points have come by. So as I turn this up, 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 the y-axis is adjusting, and now I can get all the way up to 1023 and turn it all the way down. The y-axis is adjusted again. And so if you wiggle back and forth like this, you will see some nice wiggly lines. This is what you should be seeing if your potentiometer is wired correctly and your software is running properly. So please go ahead and get this working. And then we're going to come back and examine what is going on and then give you a little assignment based on now being able to use this input.